To make the replacement motor shaft cover, I'm going to start with a circle. Choose the circle tool from the toolbar. Click it once, then type 96 and enter. This will give the circle 96 sides. Then go to the origin point, click once, and start pulling along the red axes. Type in 25.5 and enter. This will give it a radius of 25.5 millimeters and a diameter of 51 millimeters. Next, to add the hex head portion on top, choose the polygon tool by clicking on the polygon in the toolbox. Then click the origin in the middle of the circle and start pulling along the red axes. Type in 13.65 and enter. Now we need to pull the circle up to 2.3 millimeters. Click on the push-pull tool and then over on top the circle portion. Click once, start pulling up along the blue axes. Type in 2.3 and enter. Then go to the hex portion of it. Click the control key to get the little plus sign. Click the push-pull tool on the hexagon and then pull up to the face of the circle and click once. Next, click on the hexagon again and pull up and then type in 10 and enter. Now, pushing and holding on the mouse scroll wheel, turn the part so you can see the bottom. Using the eraser tool, erase the hexagon from the bottom. Next, we're going to work on the circles on the bottom. Again, click the circle tool on the toolbar and then type in 48 and enter. This will give this circle 48 sides. Since this is a smaller size circle, SketchUp won't let you use 96 sides. It'll say that the number of segments is too large. Click at the origin point and then again moving out along the red axes, type in 10.15 and enter. And starting at the origin again, click and start pulling out and type in 13 and enter. And one last time, starting at the center, click once, pull out, and type in 17 and enter. These parts will end up being the bottom of the shaft cover. Next, select the tape measure tool from the toolbar. And starting on one of the axes, I'm going to use the red axes. Click once and start pulling out and you'll have a dotted line. Type in 3.85 and enter. And do the same the other direction. 3.85 and enter. These are the guidelines for the tab on the outside edge. Next, select the line tool from the toolbar. I'm zooming in by using the scroll wheel. Click on the intersection of the second circle and draw a line out to the intersection on the third circle, using the tape measure lines as guides. Do this on both sides, so there'll be 4 lines. This is the part that will define the tabs. Now select the eraser tool from the toolbar and use that to erase the guidelines and also the extra pieces of arc from the tabs. Now we're going to pull the ring up to 5.7 millimeters. So using the push-pull tool, click on the ring and start pulling it up and type in 5.7 and enter. Next are the tabs. click the Control key once to add the little plus sign on the push-pull tool. Click on the tab and pull up 2.7 millimeters. And do the same on the other side. And you can either type in 2.7 or you can use the first one as a guide point and click on it. Need to pull them up to the top of the ring, so make sure you click the Control key so you have the little plus sign, click on the top of the tab, and then come up to the top of the ring. Next, we're going to erase the bottom portions of the tab. So using the eraser tool again, tip the cap over on its side so you can see underneath and erase the bottom portion of the tab. And do this on both sides. Next, the push-pull tool again. We're going to push the center in for the motor shaft. Going to push it till it's almost through the other side. If we bring it all the way down to the bottom face, we'll see that it's about 12.3 millimeters. So with that, let's type in 10 and enter. That'll leave a space for the plastic underneath, which we can see if we use the X-ray tool. Now to check for cleanup, click the extensions, clean it with last settings, and that will get rid of extra lines. Next, with the solid inspector, we can see that it has some internal faces and some reverse faces. If we look at the X-ray, we can see where they are to make sure that solid inspector can take care of them okay. So the internal faces are on the inside of the tabs. We can let it fix it. The reverse faces on the bottom, we can let it fix that. At last, we could clean it up a little bit more by using the extension cleanup tool again, and it'll get rid of any extra lines along these top faces. And then finally, save the item and export the STL to make it ready for printing. And this item would definitely need to be printed with support to print well.